Hi, this is Troy Tacey from Fordham University, and this is part 5 of my series of short videos on the COVID-19 pandemic. What part 5 is going to be about is answering the following question. What if Italy had not implemented the social distancing measures that they did in late February and early March and continuing on into the present day, which is currently March 21st. So what I will need to do to explain this or to answer this question is to jump back in time a little bit, just briefly into the earlier videos that we did. And here's what we know from those videos. That if we just leave an epidemic alone, we get this sort of hump-shaped increase in infections, where early on we get this exponential increase. We get an inflection point where the curve starts to flatten out a little bit. We hit the peak, and then we run off down the peak. Now, before we hit the peak of this epidemic, we can model this increase in infections nicely using an exponential function. And if we plot this exponential function on a logarithmic scale, what we get is a line. So just as a quick example, let's look at what is going on in the US right now. On the left panel, we see the number of cases in the US, number of COVID-19 cases in the US, and we see this very sharply increasing exponential graph. Now, if we plot this exact same data, but instead of using just a number scale, we use a logarithmic scale, what we see is that these cases fall very nicely on a line. Okay, so if we plot an exponential increase on a log scale, we get a line. So with social distancing, what we're doing is we're lowering the contact rate in the population. And if you remember, what this does is it lowers that reproduction number. It results in us still having a hump-shaped curve, but with that hump-shaped curve, we get a later onset of the peak of the epidemic, and that peak is also lower. But still, if we plot this out, we're still seeing an exponential increase early on in the epidemic. And again, if we plot this out on a logarithmic scale, we'll still get a line, except with the social distancing and the lower reproduction number, that line will have a flatter curve when we plot out, again, the log of the total infections, or the cumulative infections. So let's take a quick look at Italy. This Italy curve looks very similar to the US curve that we saw earlier. It looks like we're getting an exponential increase, and we are getting an exponential increase, but it isn't a consistent exponential increase. And we can see that if we just look at the log scale real quick. So for Italy, again, early on in the epidemic, we have this nice linear relationship, but note that the curve is falling below my ruler as we get out into the early parts of March. And then again, it sort of fits a nice line, but it's falling off again. So we see that something is happening in Italy. And again, this emphasizes why we need to look at this curve on a logarithmic scale as opposed to just looking at the raw number of cases. So this curve is increasing exponentially, but the exponent is getting smaller and smaller over time, and our human eye isn't very good at picking out the changes in those exponents. We just can't do it. But if we look at the log scale and we compare it to a line, we see that curve is getting flatter and flatter. It's much easier to pick out what's happening on that logarithmic scale. So what are we going to do in this video? So we're going to answer the question, what would have occurred in Italy without social distancing? And the way that we're going to do this is we're going to take the early part of the epidemic, the part that fits that logarithmic linear picture very well. So this will be before the effects of social distancing take hold in Italy. And then we're going to extrapolate from the early part of that epidemic, and we're going to see how many cases would have developed in Italy if we had just followed that same trajectory that we have early in the epidemic. And then we'll compare that to what actually happened, and we'll be able to answer the question, not only what would have occurred in Italy without social distancing, but how many cases were prevented through the social distancing measures. So here's the way that we're going to do that. So step one, we're going to fit the logarithmic data for the last week in February just using a simple linear regression. So this is the early part of the epidemic that fit that initial exponential increase very well. And we can see in this graph, so what you have are the little red stars are the log of the predicted number of cases. So that's what the model tells us we should have. And the little blue diamonds, those are the log of the number of cases that actually developed. And you can see that the little red stars fall almost exactly on the little blue diamonds for the last week in February up until March 1st. Now, if we look at this same data, but again, we sort of take it apart, not take it apart, but we put it back on the regular number scale, again, we see a nice fit for that early part of the epidemic. So step 2 then is, let's suppose that we continue on the same trajectory that we had early in the epidemic, before the effects of social distancing really took hold in the country. And we have in red the log of the number of predicted cases from the model to, in blue, the log of the actual number of cases. And again, what we see is that the actual cases are falling below the predicted number of cases, which is effectively the number of cases that we would have expected if Italy had not implemented these social distancing measures. So you can interpret the difference between this red line and the blue line as the number of cases that were prevented in Italy, except this is being plotted on a logarithmic scale. If we take this same graph, but we take it out of the logarithmic scale, what we get are the actual number of cases. So if Italy hadn't implemented social distancing, we would have fallen on this red line. And again, the red line falls right on top of the blue line for the part that we've estimated and the part where that linear relationship held. But once Italy implements these social distancing measures back in February, and they eventually take hold in early March, and again, there's this delay because the onset of symptoms, it takes a while for COVID-19 to develop and for people to actually be tested and to find out. So there's going to be a little bit of a lag between implementing social distancing and actually seeing its effects a week or two later. But we see a really big effect here in Italy, right? If they hadn't implemented social distancing, we'd be sitting on this red curve. But the curve that actually resulted in Italy for through March 8th was much, much lower. And what we see is the difference between, on March 8th, the blue line and the red line on March 8th is a difference of about 10,000 cases. So in that first week of March, Italy had 10,000 fewer cases than they would have had without implementing these social distancing measures. If we take this out even further into the future, to present day, again, this red line is what we would have expected to happen in Italy, given their trajectory the last week of February. But the actual result in Italy is much, much better. So the difference between what they have experienced and what they would have experienced without social distancing is about 640,000 cases, which is, obviously a huge number of cases that were likely prevented in Italy without these social distancing measures. So in summary, we can see the effects of social distancing pretty easily in the data as long as we plot it on a logarithmic scale. We can easily pick that up by eye. So let's jump back to the US now real quickly, because we've only recently begun being really serious about these social distancing measures in the US, and we may need to be even more serious about them in the future. But for right now, remember the US has fallen very nicely on this linear plot, which tells us not much has been changing. The epidemic has been running up as you would expect for an epidemic without any intervention in the population. So what would happen in the US if we don't implement these social distancing measures that we've started to do over the past week or so? So if we left everything alone, we're currently standing at about 23,000 cases as of today, which is March 21st. And if we just let everything keep running, we would expect by April 1st, which is only 11 days away, that we would go from about 23 or 24,000 cases today to about 500,000 cases by April 1st. So if we don't do anything, we would expect to see this huge run up in the number of cases in the US. Now, a few notes on this. Hopefully then, as we introduce these social distancing measures in the US, we would hopefully see this log plot flatten in the coming week or two. In the US, however, we've been vastly under testing relative to many other countries. So the trouble with just looking at the case data in the US is going to be that as we increase the amount of testing that we do, we could actually see an increase in the number of cases and an increase in the log number of cases, which would result in an increase in the slope of that logarithmic plot that I've been showing you online. So it might be a little bit difficult to see those effects of social distancing in the US as clearly as we see them in Italy, but we still may see something. So it's hard to tell. It depends on how effective social distancing is relative to the increase in testing that we'll be doing here in the US in the coming days and weeks. So one thing that we could do is, instead of looking at the cases in the data, what we could do is look at the data for the number of deaths in the US. So again, this is following on a logarithmic scale pretty closely to a line, and because deaths don't depend upon the amount of testing that happens, it may more clearly, the effects of social distancing may appear more clearly by looking at the death plot as opposed to the case plot. And we can already see in the US probably the effects of increased testing, because if I hold my ruler up here, the last couple days, and this is probably difficult to see, but the last couple days I've actually seen an uptick, at least on the logarithmic scale, relative to where we have been, or the trajectory that we have been on. So it may be most useful to look at this scale of deaths, the logarithmic scale and the death plot, as opposed to the plot of the actual number of cases. Now again, these statistics could potentially become a little bit difficult to read if our healthcare infrastructure begins running over capacity. Again, that may muddy the waters of being able to look at things cleanly on either the case scale or on the number of deaths scale. And again, if you want to take a look at this data on your own, everything that I've shown you in terms of the data has been from worldometers.info. I should emphasize that I don't have any affiliation with them. That's a sort of a quick and easy place to get this data, and also to plot it on a logarithmic scale. So if you want to just kind of watch what's happening on your own, that is a place that you can go to look at this information. So what am I going to do next? The next video, which will be sort of the culmination of this basic introduction to epidemiology and trying to explain what's going on with the COVID-19 epidemic. So the last video, what I'll be looking at is, how do we know when an epidemic will peak? So as we are watching the data, what clues can we look at within that data to tell us if we're getting close to the top of that epidemic that we're currently experiencing? And we'll answer this question by revisiting both the reproduction number R, as well as the concept of herd immunity.